everybody, and welcome to our second keynote on this day at JCON with Josh Long, and we will be at the keynote right now. But I want to talk a little bit about JCON. We are very happy that you're here with us, that you join us, and on behalf of the whole JCON team and our sponsors, I'd like to welcome you all to this keynote and to all of our sessions. And we got really nice and great content for you. Check out our session planner. We will be on today for a few more hours, and then again tomorrow and until the end of the week. And make sure that you see all the sessions and find the sessions you like to attend. So our content board was really in the works. We had over 300 sessions submitted to JCON, which is great. Thank you for everybody that helped select the sessions, and also to everybody that submitted, also to those people who submitted and got not to present their session. We only had 150 slots available for this conference, and it's great to see that so much interest is there to share. So please continue to do so. And at this conference, you can see over 110 speakers, 150 sessions, and we have attendees from all over the world. We have now, during the day, it ramped up to almost 80 countries, and 6 continents, of course, and 2,600 attendees. This is really great. So thank you everybody for being here at JCON. And a special thanks to all our sponsors that make JCON happen. It's great that they support the Java community. So make sure that you visit their websites, check out their products. This helps JCON and helps that we can do the conference as we do and give away the tickets to the Java community. I'm very happy that I can tell you now that we are planning JCON 23, JCON People, where we will be in person in June in Germany. So this is going to be great. We're really looking forward to meeting you all again in person. And for everybody that is not able to come to Germany at this point, we're also planning to do a conference in November. And this will be the same format as this one and will be worldwide. So save those in your calendar. The last thing before we go to our keynote session, I would like to remind you to check out our feedback session. Please give the speakers feedback. They really appreciate it if you could click on one of the smileys at the session planner once the session is done. And please write a sentence or two to let them know what they did good or what they could improve on. This really helps us as the speakers as well as us when we plan a conference, so we can make sure that you get great content and the speakers can improve on their content. So with no further ado, I'd like to welcome Josh Long. Josh, it's great that you are with us live from San Francisco. Thanks for getting up for us and giving this talk on Spring Boot. And we are really eager to learn what's new and what's coming in the Spring Boot world.
Well, thank you so much for having me. I appreciate the opportunity. It is so great to be here, as you just said, live from sunny, actually uncharacteristically sunny San Francisco today. Can I borrow the screen, by the way?
Yes, please go ahead.
Right, very good. All right, very good. Thank you for having me. Good morning to everybody. I appreciate that there's a lot of places you could be right now, and yet somehow you're here with me this morning, and I appreciate that. My name is Josh Long. I work on the Spring team as a Spring developer advocate. I'm a Kotlin Google developer expert, a Java champion, and most importantly, I'm at your service. So should you have questions, when ineluctably you have questions, please don't hesitate to reach out to me. I'm on the internet. There are my coordinates. You can find me on the Twitters or LinkedIn or via email if that's your thing. I've got a number of blogs these days, but more often than not, I post on the Spring IO blog, and got a new book on which I'm slowly working on a slight minor update called Reactive Spring, a YouTube series on YouTube there called Spring Tips, for which you can find the code on GitHub. I have a podcast that comes out every Thursday with new episodes where I talk to people that are smarter than I am, which, being completely honest, it's a very low bar, super low bar, but nonetheless, there's that. And on occasion, every now and then, I might stream, right? So I'm out there, I do my level-headed best, and I love to help people find their way to success in terms of Spring. And that's what we're going to try and do today as we talk about Kubernetes native Java. Now, Spring is interesting to me because it sits at the crossroads of so many different communities, right? If you're trying to build applications that do any number of different things, that care about any number of different things like security and integration and batch and messaging and big data and event sourcing and messaging and publish, integration and security and all these other things. There's a framework that lives in the Spring ecosystem that will serve you there. And so I just love that about the Spring ecosystem. I love how robust it is. I love how things, are always, it seems like there's always something new and amazing to compel, to propel the community forward, right? I just love that. I love that the richness of the ecosystem. One of our sponsors for this show today is MicroStream, right? And they are doing, they're working on an integration to make their amazing technology work even better with Spring. So I just love that kind of robustness. I just love it. I just love it. I love the ecosystem. That's why I'm awake, right? That's what makes me jump out of bed every morning, is just to know how big and how really, really comprehensive this community is. So today, my friends, we're going to talk about another one of those communities, basically the cloud, right? We're going to talk about building applications for production, where today, as often as not, production is Kubernetes, right? To me, Kubernetes is, it's lovely, it's fine, right? But it's not the means, it's not the reason for the season, it's not the reason we're here. What I care about, what we should all care about more than anything else, is production. I love production, right? And so we're going to look at today a number of different patterns that you can embrace to build applications that work well in production, okay? And obviously with a kind of continuous sort of acknowledgement of the fact that production is, for a lot of people, going to be Kubernetes. And we're going to do that. We're going to look at all this stuff today in terms of the latest and greatest wherever possible. You see, we're at an interesting juncture at this point, my friends. It's September 2022. I can't believe it. And as we talk, we are now less than 4 months away from the end of the year, and with it, Spring Boot 3 and Spring Framework 6. And this new release, these new generations of frameworks are a whole new generation, a whole new level on which to base our applications. Spring Framework 6 will be the first version of Spring, of the new first major version of Spring, since 2017 September. It's been about 5 years at this point since the last major version of Spring came out. Obviously, we've had countless, minor updates since then, right? So obviously today we're on Spring Framework 5, right? But that generation of technology originated in September 2017. And, with this new generational change, with this new baseline, comes an interesting opportunity to elevate the baseline, to require all of us to move forward a little bit, to help us move forward a little bit. And so Spring Framework 6 will be the first to, first of all, have Java 17 as a baseline. Okay, and that's a very big deal. Java 17 it's a very nice language. I hope you're already using it. If you're not, you should be. Java 17 today is already one version behind, right? We're actually at Java 18. That's the current GA supported version of Java. Current long-term supported version of Java is 17. And by the time Spring Framework 6 releases, Java 19 will already be out. So it'll already be 2 versions behind by the time Spring Framework 6 releases. And if you extrapolate forward, remember, we support the major version of Java for as long as the life of the framework. And so in this case, it's been Java 8 since 2017, right? Java 8 is a creakingly old version of Java that makes no sense in any context today, and yet you can still use it with Spring Framework 5. We certainly don't recommend it. We wholeheartedly discourage it, but you could do it, right? That's how good the long tail of software is. And with Spring Framework 6, we can't see the future. Obviously, I can't know for how long Spring Framework 6 will exist. I don't know the future, but let's just extrapolate forward. Let's suppose it's yet another 5 years, right? Another half a decade, another 20th of a year, of a century, right? Spring Framework 6 will be based on Java 17. There's a new version of Java that comes out every half year, every 6 months. And so therefore we'll have at least 10 more versions of Java between now and Spring Framework 7, whatever that looks like, right? If that timeline holds true, if we can extrapolate forward a little bit like that. So 10 more versions, and we're already 2 versions behind. That means that you could, in theory, be using Java like 29 and still be on Spring Framework 6, right? Maybe it's a little bit more, maybe it's a little bit less. I don't know. We don't know. But my point is just imagine that situation. So while Java 17 seems a little aggressive today, it's really not, and especially considering the implications, right? Imagine running code on Java 17 in 5 years when people are already using Java 29, right? It's going to be an interesting time indeed. So Java 17 is a new baseline. Another thing that's interesting about this new Spring Framework release is that we're upgrading our Jakarta EE dependencies, right? So we've used Java EE dependencies, and then for reasons that have nothing to do with technology and everything to do with politics and lawyers, I'm afraid, the new version of Java EE, christened Jakarta EE, is now an open source project, which is great. But as part of that, the packages have changed, right? And because these packages have changed, there's going to be a slight breaking incompatibility. That is to say, everything that's ever used JAVAX, JAVAX dot asterisk, will now have to use Jakarta dot asterisk, right? So Jakarta dot validation, Jakarta dot persistence, Jakarta dot this, that, and the rest, right? As opposed to JAVAX dot persistence and JAVAX dot validation and so on. And again, from the technical perspective, the good folks over at the Jakarta EE Foundation, the Eclipse Foundation, have done an amazing job of making this transition as painless as possible, right? And so, we had a release of Java EE with a new license, and then another one with the new package, and that are basically backwards compatible with in every way except for the package itself. And so we've had several versions. We have several versions of Runway, but now it's time to actually make the jump, right? We're all kind of required to make this jump just because all the libraries that we use are in turn now using Jakarta. So Apache Tomcat and Jetty and Hibernate and all these other things, it just makes sense naturally. So there's that. You have to be aware of those changes as well. I would be very surprised if there's not a very big, prominent "that was easy" button in your favorite tooling to make migrating your code, which basically is a find and replace, easy as possible, right? So we've got that. We've got the new Jakarta EE revisions. We've got the new Java 17 baseline, and we have in Spring Framework 6 built-in support for building ahead of time code. That is to say, we have a mechanism that allows us to compile our code proactively at compile time, and to reify, to make concrete the state at runtime at compile time. So we've got all these new things in Spring Framework 6 and Spring Boot 3. We're going to see some of them today. We'll build this first module using Spring Boot 3.0 snapshot. I'm going to call this customers. Okay, customers. And we're going to bring in the web support. Let's bring in JDBC support and H2. Okay, so I'm just going to bring in those very basic dependencies. I'm going to bring in the Spring Boot actuator, and we're going to hit generate. So is that data JDBC? I wanted that too. Whoops. There we go. So we'll add this, show this in the Finder, generate. Very good. All right. So let's open this up in our IDE. Now, obviously, I'm a big fan of Java 17. Java 17 is the right thing to do in 2022, my friends. It's way better than Java 8, markedly better. It's technically superior in every way. It's faster, more robust, more performant, more syntax rich, more secure, more optimized for cloud than Java 8 in every way. It's also morally superior to Java 8 in every way. You will not like the look of despair and sadness in your children's eyes when they find out that you're still using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. Judging purely by the version number alone, I think we can all agree that Java 17 is more than twice as good as Java 8. And so for this reason alone, I think the evidence is clear. You should be using Java 17. So we're going to use that. We've got a new application. Now I want to take advantage of the AOT support in Spring Boot 3 and Spring Framework 6. A part of this is that there's a lot of metadata that needs to be fed into the Gravium native image compiler. These things are called configuration. We call them hints. And these files, these little JSON files, have information about the things that Gravium should keep when it compiles the native image. And that information can be, buttressed or enhanced by extra metadata available in a repository called the Reachability repository. This is a collaborative effort by different technologies in the ecosystem, including the Spring Team's contributions, to make common libraries accessible for Gravium, right? For Gravium compilation. So that way we don't all have to reinvent this. So I'm redefining the plugin that we've already defined in the parent. I'm redefining it to include the latest, greatest version of that repository so that we have some of those things on the class path. Okay, so now here's our public static void main application. We're going to build an application that talks to a database. I'm going to call this, we're going to create an entity called a customer here. And we're going to have a primary key. Okay, I'm going to create a repository, customer repository, extends CRUD repository. Okay, and then I'm going to want to, write some data to the database, but of course, to do that, I need a schema. So I'll create a schema here, create table, customer ID serial primary key, name var car 255 not null. So I'm creating a schema. That's my basic entity. And now I want to write something to write data to the database. Okay, so application listener, application ready event. Okay, so when the application starts up, this callback interface, this listener, will be given a chance to run. And when it runs, I'm going to write some records to the database here. Okay, so for var name, and let's just put some people on the Spring team in there. Stefan, me, hi, Jürgen, the one, the only, the amazing, the legendary. We've got Yushin, we've got, these are all just as amazing. Okay. Okay, good. So just a few random names there. And for each one of those, we're going to write the record to the database. So repository.save new customer. Null for the ID, write that in. And we'll say repository.find all and just log out the results. Yeah. So print line. Isn't that nice? Very simple code. Java has become so elegant and so expressive these days. And I love these records. These are Java 8 records. Look, Ma, no Lombok, right? I'm just writing a little record and it works. Okay. So there we go. It's worked. There's our application. It's up and running. We've got data in the database. We've got the output in the logs here. Great. This is not that interesting, right? Nobody cares about writing, a simple CRUD thing. Maybe we do want a controller though, an HTTP controller. So class customer HTTP controller, private final customer repository. Add the constructor parameter, get some data from it. So we're just going to create a endpoint here that gives us all the data from the database. Okay, so customers return this dot repository to find all. Oh, what is this now? What do I get back here instead of what I wanted? It's an iterable, isn't it? Fantastic. So iterable. Okay, so let's just restart this and see what that gives us. Okay. Localhost customers. There we go. Okay. There's our data. It has worked. Of course, it's worked. It was a demo. That's not what's interesting, right? What I want to talk about is how to get this to production. So I've got a few use cases I need to care for first. First, I need to care about observability. And to that end, I've got the Spring Boot actuator module on the class path. And this gives me a number of different endpoints. So let me see, show details for that always. It gives me a number of different endpoints. We're not going to look at them all, but what we want to look at is the health information. Okay. So let's restart. Okay. And go here, actuator. There we are. There's all of our management endpoints, all the different data from there. In particular, we care about the health endpoint, and this gives us information about the state of about the different subsystems in the application that, were they to fail, would imperil the state of the overall service. So things like the database, the file system, the connections, etc. We can we can contribute to this. We can also, add our own custom health indicators and the like. What's interesting here is that if you're in a Kubernetes context, you care not just about a health check, but you care about two particular kinds of health checks. One's called a liveness check, and another one's called a readiness check. And you configure these on your pod or your deployment and the pod spec. And what these are used for is the container orchestrator, Kubernetes, checks these to see first with the readiness indicator if the service is ready to be put into production, and with the liveness indicator to see if the service is worthy of staying in production. If for whatever reason there should be something wrong, if the service should become sick, then they will start returning the status : down, and the status code will turn to 500 something, right? This will tell your load balancer, hey, this service is sick and should no longer be in the rotation. The question then is, what happens? Well, if your application gets shut down, then you want to control how it gets shut down, right? And by default, we have something called immediate shutdown. But in the graceful shutdown mode, what will happen is Spring will stop any new HTTP requests. It'll stop the new processing of requests, and it'll give you some configured interval of time. So timeout per phase is 30 seconds. It'll give you 30 seconds to taper off any existing work. And by the way, you have to configure an equivalent value in your pod or your deployment descriptor. It's not just here in your Java code, right? So 30 seconds, you finish off any existing work, stop accepting new work, and that'll allow you to gracefully shut down your application before Kubernetes sends a SIG kill. So you get SIG term, then you have 30 seconds, then you have SIG kill. This is very convenient because now you can gracefully handle state. This is a big part about being cloud native, is that startups and shutdowns shouldn't be important, right? You shouldn't have state in the service anyway. So it should be cheap and easy to do that. Here, you're just making sure that when your service does become sick and for whatever reason it needs to be shut down, it can do so gracefully. Now, obviously, I've looked at a number of things here, the readiness probe, the liveness probe. I've looked at graceful shutdown. You might argue that this is stuff that's only supposed to be in in Kubernetes, right? So you can actually import configuration using a number of different mechanisms, and one of them is called a config tree. If you have a config tree, it's basically the directory structure that gets created when you mount a config map as a volume in Kubernetes. That's what we call a config tree. And so if you take a config map or a secret, it's a bunch of keys and values. You can tell Kubernetes, hey, mount those keys and values as a directory structure. We make those available to you through this config import mechanism. So I can say, hey, I want to import the config tree. Let's just suppose I'm running in Kubernetes that lives over here, right? Config /. And if that's the case, I go to my desktop, make dir config, cd config, echo application, or I'm sorry, echo server.port, and we'll say 8090, okay? So here I'm importing config from this config tree. I've got a directory structure full of files whose names are corresponding to the config map keys, whose contents correspond to the config map values. Okay, so I'm importing that from here. If it's worked, then you'll see that this will start up on port. What was it? 8090. Okay, so it worked. I've successfully overridden the default there, which is great in a Kubernetes context. So you can actually use something like this. You can add this to the -d arguments or something like that, and it'll pull in configuration specific to the configuration in Kubernetes. You can also use environment variables. So again, it's very nice to have layered configuration, have local defaults, but use things like this to add extra configuration that gives you more appropriate values for the context you're in. Okay, so we've got an application. It's configured, it's observable. We know what to do when the application is ready to go to Kubernetes. That said, I do want to take it to Kubernetes, and there's a lot of things I need to care about there in terms of packaging. One unique opportunity about which I spoke already is Gravium native images. Now, Gravium is an amazing OpenJDK distribution with a drop-in replacement for a hotspot, right? It's a just-in-time compiler. It is now more commonly known, strangely enough, for a separate and formerly optional component called the Gravium native image compiler. And indeed, when we talk about Gravium, me included, most of the time, we're talking about native image compilation. What this is doing is it's doing what this compilation does is it looks at your code after it's been compiled, and it does a reachability analysis. It looks at all the code that your code is using, and all the code that your code is using, and all the code that code is using explicitly. So import, and then you're actually instantiating or referencing that type somehow. And it says, okay, great, I'll keep that class in the memory of the native heap, right, of the native image. Everything else it throws away, right? It goes down this line and it looks at everything in your code, everything in the class path, everything in the JRE. If it cannot determine for whatever reason that you're using this type, then it'll throw everything away that isn't being used. This is a bit of a problem, however, because Java is super dynamic, right? For all of its stodginess and words, it actually has a lot more in common with the likes of Ruby and Lua and Perl and Python and JavaScript and Lisp and all that. It has a runtime. You can actually take a Java lang string, compile it at runtime after the application is started into a .class file, load it into the class loader, reflexively create an instance of it, call methods on it, create a serialized instance of it, create an invocation handler proxy out of it, and so on, all after the application is started, all in terms of Java lang object and just reflection types, right? All of that would be completely invisible to the Gravium native image compiler. So you have to feed it configuration. These configuration files are what I talked about earlier. They're hints, and they give Gravium a sense of what extra things you're going to do at runtime beyond the stuff that it can already figure out by doing this reachability analysis. That's what that metadata repository about which I spoke earlier supports. It contributes common metadata for common ecosystem library technologies like Tomcat, like Log4j, or whatever, whatever's out there that people want to use, we support it. Or we're trying to. We're working as often as not with those projects so that they can be the maintainers of this metadata. Okay, so with that in place, there's still your Spring code, right? Your code is going to be different from every other person's code, so it makes no sense to store that code in one particular place, because as soon as somebody comes along and tries to do something a little bit different, then it would break. So what we have here is another mechanism in Spring Boot 3 itself. It's a AOT engine. At compile time, Spring starts up your code as bean definitions. It doesn't start up the actual objects. It doesn't instantiate and call the constructors and all that stuff, but it creates a version of your Spring application context that looks like what it's going to look like at runtime. And at that time, you can write code to process all those beans in the application context and, reflect upon them, to introspect them, to look at them and say, oh, you're going to need hints for this annotation because that implies this, and whatever. So you can programmatically, with these callbacks, contribute hints for reflection, for serialization, proxies, JNI, loading resources from a jar like application app properties. All that stuff is programmable, and Spring Boot 3 does that a lot. So if you want to kind of see what we're doing, just look for all these different hints. So here's an example of a hints class. It's a free marker runtime hints, and it's it's doing all this stuff inside of here, and I won't go into all the code, but basically it's programmatically pulling in hints for free marker if free marker is being used. So it's part of the auto configuration code now, right? So you'll see hints all over Spring Boot 3. This mechanism is, of course, it originates in Spring Framework 6, and now Spring Boot is natively taking advantage of it. So the result is that for a huge swath of applications, it should just work. That's what we want. So let's do that here. Let's say Maven P. We're going to use a Maven profile called native. I'm going to skip tests. We're going to say clean package, and we'll say -u, and that's going to compile the code, pulling in the latest reachability information. And hopefully we'll get a Spring Boot application that runs in a native context out of this, right? So we've got a trivial application, but I haven't done anything in particular to make it work in Gravium. I don't need to at this point. It's nothing too special here. So you can see that's not the test. I skipped tests, and yet Spring actually created a version of the application context that we can then, that the infrastructure code in your code, if you wanted to, can then post process. So it's going to run in the background there, pulling in the latest dependencies. Let's let it do that. This will take, 30 seconds, 45 seconds, a minute. And it actually, you can also use our build pack support. Build packs are a great way to take an asset like an application and turn it into a Docker container. That build pack support, it allows you to take this application and turn it into a Docker container that you can then Docker tag and Docker push to your container registry of choice and then use. Here we're using the local Mac compilation. So I'm building a Mac OS native image. But if you built a Docker container or a Linux container, then what you get is you get the code for your application being compiled within the Docker Linux container. And then the resulting binary, the native binary, would be a Linux binary, right? So you could then run that on anything that supports Linux. Okay, so there's our build. I think it's taking a lot longer than normal because I'm screencasting, right? I'm actually using the CPU there. So there's our application, right? You can see the application is fast. It starts up quickly. What's interesting to me is the memory footprint. So there's our PID, there's our process identifier, right? And I've got a little script here, bin RSS by PID. Okay, that's that script. And you can see all it's really doing is PS -O RSS and then passing in the PID, and then everything else is about formatting. So let's try that. So this thing is taking 111 megs of RAM, and you'll find amazingly somehow that this is actually even more efficient on Linux. That's, what is that, like a 1/10 of most people's application footprint, right? That's a good deal right there. You take your applications, turn it into a native image, and now you have something that will run in 1/10 of the footprint of what you have in production. There are some limitations to this. Obviously, nothing is free. So first of all, obviously, you can't take your Linux binary and then run it in Windows, right? You need to compile. You need to do cross-compilation there. It's easy enough to do that with GitHub Actions and with the Gravium GitHub Action in particular, so you can use GitHub Actions to do things like matrix builds, where you do one permutation of the run on Windows, and then another one on Linux, another one on Mac, and so on. But this opens up using Spring in all sorts of new contexts that didn't otherwise make sense. So for example, why not build a Kubernetes operator, right? It takes no amount of RAM, basically. It would actually take less RAM than this. So you can actually build something that takes, 70 megs of RAM as opposed to 700 or 1,000 megs of RAM, a gig of RAM, right? You could do, remember, you can actually take Gravium images and turn them into .dylibs and .sos and .dlls. You can actually link to your Spring Boot application from, iOS, for example, right? There's some really interesting opportunities here implied by this technology. The other thing that's really interesting about this to me is that suddenly things like shell applications become more palatable. You can actually write a Spring shell application, and that turns into native images with no problem. So I'm a big fan of this native support. There's just some really interesting opportunities. The speed is great, obviously, and here I'm using Tomcat. I'm using all that stuff. If I were using a reactive, it would be even faster, much faster, But still, it's just 1/10 of a second, right? It's a sorry, it's a 1/10 of a second. It's 100. Is that right? Yeah, that's right. So it's nothing, right? Nothing at all to get an application that has its own database, its own web server, and all that stuff embedded. Okay, so now we've got an application. Let's build a client here. And this client, we're just going to call this Edge 1. Okay, and here I'm going to use the reactive web support. I'll use Spring Cloud Gateway, and I'll use GraphQL. Okay, so here we've already built a Spring Boot 3 application. For now, I'm just going to use Spring Boot 2 because I haven't really tried all this stuff out. Well, I'm sure it'll work, but I haven't tried it all out on the Spring Boot 3 side, so let's do that later. And this is going to be a thing that talks to our downstream service. And here you're going to want to have technologies that give you an easy way to consume downstream services, right? So here's your first port of call, your entry point for applications. Your entry point for applications that don't know to what they're supposed to be routed, right? So for example, if you have an edge service, it can handle client-specific distinctions, things like headers and URL query parameters and things like that. All that can be normalized at the edge and then forwarded down to the right service through routing. And the one natural way to do that routing is to use Spring Cloud Gateway. Okay, so being route locator gateway, route locator builder, RLB, return routes.build, okay, route rs.path. And so what I'm saying is when somebody goes to the port on which this edge service lives, server port 9999, Then they're going to get when a request arrives, it's going to go through this predicate, this test here. It's going to say, hey, is the path for the request / proxy? Great. If so, forward it to this URL, right? Localhost 8080 / customers. The problem is it's going to take the existing request, including all of its constituent parts like the path, and forward it to this. So we need to swap out the path. So here's where Spring Cloud Gateway's filters can be so useful. I'm going to say that the path has to be customers. I'm going to take the existing request, which is path / proxy, swap it for / customers, and then send that otherwise unchanged to this other original service, that localhost 8080 that I've got. Okay, great. So let's just see what that looks like. Okay. So localhost 9999 / proxy. And there you go. You can see we've got our data on port 9999, even though the service lives on port 8080. Here, I could do things with these filters. That's where the real power is. By the way, that's a macOS M1 issue. So if you want to fix that, you just do this. You say nitty all, refresh. Anyway, I could change things in the code by using these filters. These filters are where the real power is, right? I can say, okay, do a rate limiter, or do a retry, or add a response header. I can do all the sorts of things you might do with something like Nginx or mod rewrite or Kong or whatever. All that kind of stuff is a natural fit for this sort of lightweight API gateway. Okay, great. So I really, really powerful. This is a great way to connect the outside to your downstream services, and to give them a slightly adulterated view of the data. But basically, you're not changing the envelope of the data. You're changing the headers. You're changing everything about the message except for the message proper with the gateway. Sometimes you might need to. Sometimes you want to like create a view of the data that's different from what the actual data looks like behind the scenes. And this is very common. And it's one of the reasons why Facebook, at the time called Facebook, created GraphQL back in 2012 and then open sourced it in 2015. So what I'm going to do is I'm going to create a folder here called GraphQL. And in there, I'm going to create a file called schema.graphqls. And I'm going to describe some types that I want to be available. So I'll say type customer, ID, name, string. So this kind of matches up with the type that I have over here, my customer type, right? But let's say I also want to introduce another type, a profile. Okay, so type profile. What is that? ID, okay. And let's say that I want each customer to have its own profile reference. So maybe there's some object in another microservice, okay? I can describe that mapping here, independent of how these things actually live. The customer service might be written in Java and Spring, and it might be a Gravium native image. The profile service might be, an old classic Spring application that isn't running on native. It doesn't matter because these are just two different services from which I could draw my data, but I can compose them in such a way that they look like one composite aggregate thing at runtime. Now, of course, this is the data structure, but I need some way for the client to discover all this stuff. And so the convention there is to have a type called query. And here, I'm just going to create an endpoint that returns 0. That's what these brackets are, 0 to n customer references. So query is kind of like the root conventional type for all read operations in GraphQL. Okay, now I want to make this stuff available so that we can introspect it and stuff. So I'm going to say graphical enabled is true. And then I have to actually implement that GraphQL controller. Okay, so I'm going to use Spring for GraphQL here. So CRM GraphQL controller. And you can see I'm just using regular @controller, same @controller as you've seen before. This is, remember, this has been in Spring for, since 2.5, which is 2008, 2007, something like that, long time, right? And this has never been about HTTP. It's just about taking a protocol and adapting it to your business logic. It's a generic annotation. And here, we're using it for GraphQL, but you can also use it for WebSockets and RSocket and MVC views and REST and all these other things, right? Okay, so CRM GraphQL controller. I'm going to use the web client here. the reactive non-blocking web client. I'll inject that into the constructor. And I'm going to create an endpoint to, to satisfy a request for this query customer's handler, this field. So I'm going to say the type name is equal to query, and the field name is equal to customers. And whenever somebody calls that, I am going to return a reactive stream of customers. So I'm going to create a DTO here of that type, right? And this DTO will in turn, I'll get the data to feed to provide the data for the DTOs by just using this reactive non-blocking HTTP client. So localhost 8080/customers, retrieve body to flux customer.class. Okay, so there's a reactive non-blocking HTTP call. And I'm doing it like this. I'm saying for the type query for the field customers, when somebody wants to get that part of the object graph, call this method back. But what about the profile? Okay, I don't actually have a profile service running, but let's suppose I had the DTO and I wanted to then make that part of the graph appear. I could do schema mapping, type name equals customer, right? Now the type I'm providing a handler for is for the profile feed, profile method on the customer itself. So here's the profile. And I can't look up the profile unless I have a pointer to the root aggregate type, the customer. So I'm going to inject that customer here, and I'll say return new profile customer.id. All right, there we go. So I've got now schema mapping. This is kind of like request mapping, right? It's low level, but you can actually use some more concise meta annotation. So here I can use query mapping, in which case the default type name is assumed to be query. And actually, if you want, you can drop the explicit field definition and just rely on the name of the method. So even here, I can simplify things by just dropping that. Okay, so the type name I have to explicitly specify here because there's no annotation for that. But for queries and for mutations and subscriptions, there are some options. So let's go ahead and restart this. Oops, I have to define a reactive non-blocking HTTP client. No big deal. Okay. Goody. So now, localhost 9999 graphical. Okay. So here's a little console you can use to interact with your data. And so I'm going to say, I'm going to run a query asking for the customers, asking for the ID and the name. The nice thing about GraphQL, though, is I can get as much or as little of the data as I want. So here, I'm asking for the ID, the name, and the profile data. But if I don't ask for the profile data, then first of all, I don't get the data back. And second of all, this method doesn't get invoked. Here, I'm just returning a new profile. But realistically, you'd probably be making some other network call to get that data. So you'd have an n+1 problem. You can actually simplify that by using batch mapping, right? In which case the contract would be you have to return for all the customer objects, you'd have to return profiles. And you have to do it in terms of all the customers that you get here, right? So if you want to simplify things, if you want to avoid the batch problem, the n+1 problem, you can just say, hey, select all the customers, select all the profiles where the customer in maybe in this list of IDs that you get from the list of customers. You could do that as well. In which case you could comment this out and it would be the same result. We don't have enough time to get fully into GraphQL, but it's really, really impressive what's possible. My friends, we've just looked at some small things here. I hopefully give you a kind of a brief tour of things you can do to make your application work well in a cloud environment. We looked at observability. We looked at the brand new latest and greatest in Spring Boot 3. One thing I forgot to mention is that in the Gravium native image world, there's no support for Java agents, right? Like I said earlier, there's no such thing as a freelance. There's always concessions and compromises. Right now, Java agents don't work. So you're going to need to look for some other ways to do observability. We have, of course, the amazing Micrometer project for statistics, and we have Spring Cloud Sleuth for distributed tracing. That's getting better in Spring Boot 3. There's now a new observation API, okay? And this API gives you one unified abstraction for both capturing metrics and for capturing trace information. So you have one unified type supported from Spring Framework on up. It's not you don't have to use Spring Cloud over here and micrometer over there. You can have one API that Spring Framework itself will bring in. And so that'll make it much easier for you in your code at runtime to capture data, right? So that you don't need a Java agent for. And it's yet another thing. It's coming in Spring Framework 6 and Spring Boot 3. Anyway, I hope you got something out of it. I hope you learned something. We've only begun to scratch the surface. Obviously, there's so much more we could do, but we're just out of time. I'm happy to answer questions now. And thank you again for having me. I'm going to stop sharing. I guess I shouldn't stop sharing, huh? I think I was told not to. Is somebody going to read the questions, or do I just, how do I do this? Let me stop sharing so I can look at the questions. Is there a relationship integration within Spring RTBC supporting Spring 3.0? So right now, I literally, like the last few days, we've been working on the Netty hints, the configuration for Netty. So like you saw, I'm already using Spring Data JDBC, and so much of what we're doing is just a matter of getting the hints into that reachability repository. So I expect RTBC, if it's not already supported, it will be by Spring Boot 3 due later this year, obviously. That's the plan. And by the way, we had that working before with Spring Native, which is our sort of experimental research project in which we did all this. Why doesn't Spring support Scala as a first-class language like Java and Kotlin? Great question. We did. Did you know there was actually a Spring for Scala project that we had like 10 years ago? And we did our best. We provided a whole configuration programming model and tried to provide more functional equivalents where it made sense. And nobody was interested. Like, there's not a huge cross section of people using Scala who also want to do this kind of style of app or something, I guess. I don't know. I like Scala. I've always been a fan. I've even done Spring tips videos, YouTube videos, if you go look for them, Spring and Scala, beautiful Scala, something like that, where I even looked at how you can use Akka streams, for example, with reactive APIs, all from within the Scala language. So I built a Spring Boot app there. So yeah, no reason except that there's no appetite for it, it seems like. But we actually did try. We might try again. If there's a overwhelming demand for it tomorrow, then we'll see. Play framework stands against Spring Webflex. Play framework is, I don't know what the state of that is these days. I have no idea. But obviously it's not really Spring Webflex versus Play. It's Spring versus Play, and Spring is a massive ecosystem with decades of rich community, whereas Play is a web framework that has, as far as I know, there's not a lot of development there. I don't know, maybe it is, maybe I have no idea. I could be very wrong, but I don't see a lot of people using it, but I'm sure it's great. Anything that supports reactive programming is better than the alternative, so good stuff there. Okay, well, I think we're just about out of time, so I'll wait for them to play me off the stage.